Okay, here we have our lovely kit box. I have my soldering iron, helping hand, and solder ready to go. Let's quickly open up our kit and organize everything neatly. Okay, so we have everything from our first bag separated out and grouped together. We have our ICs and sockets left in their foam, the resistors in a neat row ready for testing, then our capacitors, both the yellow ceramic and cylindrical electrolytic ones, and then our diodes and LEDs. I've also opened up the workbook ready for reference and checking off as we go along. The first thing we want to do is check the values of the resistors. As tempting as it is to assume the values based on the quantity of each, it's important that you check each of them against the workbook. Mistakes do sometimes happen when kits are packed. You can check the colours against what is stated in the workbook, however it can be mega tricky to see the colours clearly sometimes, so using a multimeter just removes all the hassle and doubt. Okay, great. Now we're all tested and I've marked the paper ends of the resistors with their values. So referencing the workbook and the silkscreen on the PCB, I'll now start placing the resistors, soldering them and snipping as I go. Resistors are not polarized, which means they can be placed either way round on the board. I will place each group of resistors onto the board before soldering up to a maximum of about 5 or 6 resistors at a time. Any more than that and it just makes soldering awkward. Oops, don't forget to wet your sponge for cleaning the iron and to tin the tip just before soldering each group of resistors. Okay, so I'm placing soldering, snipping and marking off on the workbook for each set of resistors. Oh no! Idiot. I've gone and soldered the wrong resistor in the wrong place. Okay, so no big deal, resistors are cheap and plentiful. I'll just snip the offending component and grab a spare. If you don't have a spare, you'll need to carefully remove the resistor using heat from the iron. With the resistor removed, I now need to remove the solder from the 2 solder pads. To do this, I need to rearrange my helping hands and grab my desolder pump. Pro tip, sometimes adding a little extra solder to the solder pads can help the pump remove the solder a bit easier. So, we need to prime the pump, then bring the iron to the PCB surface. Once the solder is molten, bring in the pump, make sure it's at 90 degrees to the PCB surface and press the button to release the vacuum and remove the solder. Repeat this for both holes. With that fixed, I can now finish with the resistors, and that's it. Phew. So here we need to be super careful. Diodes are polarized, and if they are placed the wrong way round on the PCB, they will not conduct. The grey band on the diode should match the orientation of the corresponding marking on the silkscreen. Again, place your diodes, solder, snip, and mark off the assembly guide. Rather than solder the ICs directly, which may damage the sensitive internals and make replacing them extremely difficult, we use sockets. It may be hard to see, but on one end of the sockets there is a little notch cut out of it. This corresponds to the end of the IC where we will find leg 1. On the silkscreen there will be an image of the IC holder with its own notch. Similarly, each IC will have either its own notch or a small dot on its top surface to identify the correct orientation. A nice trick for making soldering sockets a little easier, and why I leave capacitors until next, is to place the sockets into the PCB, making sure to mind their orientation, then placing the panel over the top of them. We can then flip both the board and the panel over and lay them flat on the table. On the table we can then solder one corner pin of each socket, which will hold them in place, and then we can return them to the helping hands to finish the soldering. In this project we have 2 types of capacitor. The 2 small yellow multi-layer ceramic fellows, which are not polarized, and the 2 cylindrical electrolytics, which are. On the silkscreen there will be a small plus or minus to indicate the polarity for the electrolytics, and remember that the long leg is the positive. First I place the yellow ceramics and solder, snip and mark off the workbook, and then the electrolytics. With the power connector, it is super important that you pay attention to the instructions in the workbook and the image on the silkscreen. On the connector, there should be a small triangle, and this indicates the minus 12 volt rail. On the PCB, there should be a similar triangle or a minus 12 volt marking. These board connectors only let the cable connect one way round, and if the board connector is then soldered the wrong way round, when you plug in the power cable, the connections will be reversed, Triple check your workbook and triple check the silkscreen before soldering. The jacks are the first of our panel mounted components. All panel mount components should be placed on the PCB but not soldered until the panel is placed at the end, so that everything fits easily and comfortably. There we are, 4 jacks sitting in the PCB waiting for their buddies. This is an example where reading the workbook is essential. In this case, we wish to remove the panel fastener tabs from the base of the pots, but not the base standoffs. Sometimes this changes and getting it wrong can cause short circuits. Okay, we've removed the tabs and carefully placed the pots onto the PCB. The last panel mounted components we have to add are the light emitting diodes, or LEDs. These are a type of diode, so they are polarized, and similar to the capacitors, they have one leg longer than the other to identify the positive side. On the PCB, there should be a plus or minus to indicate the polarity. Now I carefully place the panel over the components. Use a pair of tweezers to help you if some of the components are not perfectly aligned. I'll then start adding the securing nuts, starting at one end, then moving to the other, repeating this process while gradually moving towards the center. Securing the nuts just by hand really won't get them tight enough, and eventually they will come loose. So to secure the nuts properly, you can use a common tool such as a ratchet with the correct sized hexagonal bit or a pair of pliers. In both cases, make sure that there is some rubber or a lot of tape involved to prevent scratching the faceplate. There are also some specialist tools out there you can find, designed specifically for this job. With our panel secure, we can now go ahead and solder all the parts. Try and be methodical, marking off each component and double checking that you got each of its legs as you go, as it can be quite easy to miss one or two if you just go at it at random. Okay, well that's all our soldering completed. We now just need to add our ICs to the sockets, making sure to check their orientation. And finally, place the knobs. The trick to getting them aligned is to turn all the pots to 0 and then place your first knob with its mark at your chosen 0 point. Then you can match up the rest to this. And that's all there really is to building a DIY Eurorack from a kit. Let us know if you found this video valuable, and if you have any questions or thoughts, please leave them for us in the comments.